Okay, question 5. A cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age and the weight. Okay, so we get age on the x-axis and the weight on the y-axis. Okay, I'm just going to have x, y. A line of best fit has been drawn, so yep, there's lots of different points, and that is a rough approximation of the values. Okay, it makes sense as well, doesn't it? As the age of the animal gets higher, its weight gets bigger, so makes sense. All right. And there's 2 points. Point D is a 3-month-old calf at 100 kilos. Point D is 3, 100. So basically, that's your 2 points. Okay, it's putting it into context. That is what that's effectively saying. It's giving you a coordinate. And then point E is 15, 340. Okay, find the equation of the line of best fit in terms of A and W. Okay, well, to begin with, let's just use y is equal to mx plus c. I like using x's and y's to begin with, and then we'll change it at the end. Okay. So y is equal to mx plus c is the equation of the line. You should be aware of this. We've gone through this on all the videos if you've watched them. This is a standard line, okay? C is where it crosses the y-axis, so it's when x is 0. And m is the gradient. Okay, so m is really just the ratio of the difference in height. I'll call that difference in height divided by difference in x, okay? It's like delta y over delta x, okay? That's what your gradient is, okay? Now people might look at that and go, whoa, this looks really confusing. But really, it's just the difference, okay, in height divided by the difference in length. There's nothing confusing about that, okay? And it's usually shown with the equation y2 minus y1 divided by x2 minus x1. You think about what that is, it's how high have I travelled divided by how long have I travelled. Okay? So those are the 2 things we're going to have to work out. So let's start with n. Okay? So y2 minus y1 divided by x2 minus x1. Here we go, cooking with gas, right? So don't get confused with the context. All these questions are just straight line questions. Okay? So let's call this point number 1, and we'll call that point number 2. Okay, so y2 is 340, and y1 is 100. x2 is 15, x1 is 2. So that's 240 divided by 12. Okay, and you should be able to look at that and think, well, I know 240 divided by 12. Okay, it's just going to be 20, isn't it? But let's do long division. 12 into 2 doesn't go. Carry the 2. 12 into 24 does go. Okay, but you should just be able to look at that and see that. So I've got a gradient of 20. So quite a steep gradient. Actually, 20 is very steep. And when you think about it, it seems to make sense because at 3, we've got 100 as our. So 3 is x and we've got 100 as y. So if we had a gradient of 1, right? Oops, got the pen on, it does this. Goes wandering. If we've got a gradient of 1, okay? So just y is equal to x, okay? Which is effectively y is equal to 1x. And it crosses through the centre, so there's no c. Okay, if I drew the line up here, it'd be y is equal to 1x plus, let's say that was 5, crossed out with 5, okay? But we're just going to do the y is equal to x. That's my kind of standard that I always think about. Y is equal to x. So y is equal to x. When y is 1, x is 1, okay? That's terrible. Sorry, when y is 1, x is 1. When y is 2, x is 2, etc., etc., 3 and 3, 4 and 4. But we've got x is 3 and y is 100. So it doesn't make sense, actually. The gradient's quite steep. Okay, so again, I'm thinking that's probably right. Okay, it's a positive gradient, which is correct. A line leaning in that direction would be positive. Okay, so yep, this is positive, this is positive, this is positive, negative, negative, negative. Okay, see the directions. Yeah, I'm just going to them. So yeah, that's us got a gradient of 20, which is good. Okay, now we need to work out what C is. So when it crosses the axis, and I'm not actually sure where it crosses the axis. I can't see. If this is 100, then I would guess that's about 60. Okay, but we can't just guess 60. Okay, we need to try and see. So to work out what C is, let's substitute a point in. Okay, so let's say 0.1. So y is 100, m is 20, and x is 3. So 100 is equal to 60 plus c. So what adds to 60 to give us 100? 40. So c is equal to 40. Wasn't actually that close, but still. Right, kind of ballpark anyway. Okay, so c is 40. And the very final step is to then write that in terms of the equation, isn't it? So instead of y, we've got w. So I've got w is equal to 20a plus 40. Okay, that's your final answer. Okay, we're not finished, we're working out c. So equation of straight line, I always say this, it's one of the best questions you can get. It's very straightforward, not a lot to it, and it's the same every time. Working out m, working out c, brilliant. Okay, so looking at the marking scheme, you got a mark for your gradient, so there's our first mark. Yeah, and a mark for c, and then a mark for your final equation. Don't forget that. That's one mark. Sorry, don't forget that. That's one mark for not doing really any work. You've done all the hard work. It's just finishing off the question. Same as up here. If you didn't write that, it was 2 marks you would have dropped right away, and you didn't deserve that at all because you knew the answer. Okay. Yeah, good stuff. And part B, we've still got time. Loads of time. Part B, use the equation for me to work out the weight of a 1-year-old calf. Okay, so the equation was W is equal to 20A plus 40. Now it's for 1 mark, right? So it can't be that tricky. So we're working out the weight, so W, so there's no rearranging. We're actually working out W, and the age is 1. Okay, so I'll tell you what a lot of folk are going to do. They're going to go 20 times by 1 is 20, plus 40 is 60, and they'll write 60 in. Okay, now I can see why folk have done that, because they see the number 1 here, and they think, all right, cool. But they have highlighted the year in bold. Okay, now the graph is for the age in months. Okay, so they're a bit sneaky there. So don't, moral of the story is don't rush. I know when I'm going through these videos, I'm thinking, this guy can talk, right? I can. But actually, if you add up the time I spend doing all these videos, I'm only a little bit over. I think maybe it's 20 or 30 minutes over the time for the paper, which, consider I'm talking so much, is actually, it shows that you can keep a nice light pace and you'll get through okay. Right? So slow and steady, don't rush through, rush in, have a think. Right? Now, say we did it with, we put in 1, we would get an answer of 60, so I'm just going to write 60 over here just to remind me I'm going to get 60. In fact, I'm going to write it up here. Right, so 60 is if we put in 1, right? But it's 1 year. So everyone should know there's 12 months in a year. If you don't, we've got problems. Okay, so it's 20 times 12 plus 40. So what's 20 times 12? Well, that's just the same as 20 times 10 plus 20 times 2. Okay, so that's 200 plus 40, so it's 240. 240 plus 40. All right. So, sorry, lost my thought. So that's going to give us 280 kilograms, right? So let's go back up to the top. 280. Now we said 1 year, didn't we? 12 months. So we look at our graph, okay? 12 months is somewhere between, that's is that 3 months and 15? So 12 must be up here somewhere, okay? So it's probably going to hit the y-axis in there, right? Maybe kind of in here or something like that, right? Yeah, something like that. Now if we're saying that that's 340 up here, and this is 100 in there, I'd be looking at that thinking, yeah, okay, well, it's probably between 200 and it's probably 250-ish. It's maybe that kind of number, okay? But you can be really accurate if you want looking at that. The point though is it's not 60. Okay, 60 is down here. In fact, what was the y-intercept? 40. It's crossing the y-axis at 40. So 60 is way down here. Okay, like there. Sorry, I'm doing rubbing it. It's down here or something. Yeah, it's really really small. So point is, have a think. Does your answer make sense? Okay, don't just plug in some numbers and think, oh, that's me done. Right, have a wee think. So, yeah, 280 to me makes sense. And just checking the marking scheme there. Yeah, that's correct as well. I've just got time for question 6. Determine the nature of the roots. Now, the nature of the roots, you should instantly think discriminant b squared minus 4ac. Okay, that's a, that's b, and that's c. Okay, so it's 5 squared minus 4 times 7 times minus 1. So that's 25 minus 28 minus 4 times minus 1, minus 28. So it's going to give me plus 28, so it's going to give me 45, 53. Okay, that should really just come right off the top of your head if you're doing this. Okay, now if you forget that equation, it is shown at the beginning. It is up here. Discriminant is this part of your quadratic formula. Okay, now I'm not quite finished. I think the question was 2 marks, wasn't it? Yep, so that'll probably be your first mark. Yep, looking at the marking scheme, that's first mark. The second mark is to know what that means. Now what this means is, if I've got a quadratic, can I do 3 things? This one has got 2 roots, because it crosses the x-axis twice. This has got 1 root, because it crosses it once. And this has got no roots, because it doesn't cross it at all. The discriminant is going to be greater than 0 for this one. It's going to be equal to 0 for this one, and less than 0 for this one. Okay, and if you think about it, it does actually make sense, because when we do minus b plus or minus the square root of b squared minus 4ac, let's just say, let's just call that, the square root, in this case it would be the square root of 53, right, divided by 2a. If this number, if it's a square root of a minus number, we can't do it. Okay, so that equation would make sense, hence no roots. Okay, if this number was 0, then we get minus b plus or minus 0, so we just end up with minus b over 2a, we just end up with 1 root. Okay, if this number is bigger than 0, we're going to end up with our 2 roots, aren't we? Because we're going to have minus b plus root 53 over 2a, and we're going to have minus b minus root 53 over 2a, so we'll end up with 2 roots. Okay, so the roots are just where it touches or crosses the x-axis. And if you can't remember these things, think about what it means. Okay, so if that number was a positive integer above 0, obviously we're going to have 2 different roots, because that equation, the quadratic, would give us 2 answers. If it's equal to 0, we're just going to get 1 answer, so we've got 1 root, and if it's negative, we can't compute, so it's no roots. Okay, so the answer to this one is 2 real roots. So again, if you're not great with these things, please just remember, when you see nature of roots, do the discriminant. Okay, just do b squared minus 4ac. You're bound to get something for that. Okay, and I've tried to explain. Hopefully, this will stick with you. That's where the 2 roots comes from. Okay. The nature, yeah, that'll be okay, I think. Yeah, I was just trying to think if there's a better way of wording that. The 2 real roots. The marking scheme says real and distinct, but I think the distinct is because there's 2 of them. But yeah, the point is they're definitely real, and it talks about the nature of the roots. So it's real, and I think, yeah, saying there's 2 of them would be totally fair. So yeah, the marking scheme says real and distinct, but you'd also get a mark if you just wrote real roots. So yeah, I think 2 real roots is fine. If you wrote 2 distinct roots, that would not be okay. But 2 real roots is okay, because 2 distinct, it could be, yeah, I don't think that, but 2 real roots is okay.